I wanted to give you some extra information or some extra help on Lesson 18, which is related to a confidence interval for a proportion. You've really been focusing on confidence intervals throughout Lessons 16, 17, and now 18. The difference is in Lesson 16, you looked at confidence interval for the mean, where you were given or knew the population standard deviation. Then in Lesson 17, you also looked at a confidence interval for the mean when you were given when you did not know the population standard deviation. Lesson 18 is a little bit different because now instead of focusing on a mean, we're going to focus on a proportion, or you can also think about it as a percentage. And this particular confidence interval is again based upon the normal distribution. So in a sense, you're going to go back to the idea of computing a z interval, and we're using that bell-shaped symmetrical distribution that we refer to as the normal. And the information that you need for finding the confidence interval for a proportion is quite different from what we had previously. For a proportion, you need what we call x, n, and the confidence level. Okay, x is what we refer to as the number of successes. How many times do you basically get what you want? If you're flipping a coin and you want to flip a head, then how many heads did you get? If you're rolling a die and you want to get, say, a 5, how many times did you get a 5? Okay, so the x is the number of successes. N is, again, our sample size. How many did you have total? And of course, CL is our confidence level, which again is most likely stated as a percentage, but it can also be stated as a decimal. Now, you're going to see, really, it goes on behind the scenes for the most part, but there are some additional symbols or notations that you'll see. You'll see a value called p hat, or sometimes it's written p with a little apostrophe. Okay, this is your sample proportion. What did you get when you performed your particular experiment? And it's calculated as x, your number of successes, over the total. We also, if we talk about success, we also have to talk about failure. Okay, so in some books, they use the letter Q to represent a failure. And the formula for Q is 1 minus the p hat, or actually, excuse me, not p hat. It's just 1 minus p, 1 minus the proportion. Okay, so you'll have some other symbols and things in there that we'll talk about as we go. But again, all of this can be done on your calculator. So I want to look at a couple of different examples. And in this first example, it reads, in the computer game World of Warcraft, some of the strikes are critical strikes, which do more damage. Assume that the probability of a critical strike is the same for every attack, and that attacks are independent. During a particular fight, a character has 257 critical strikes out of 742 attacks. What is the lower bound for the 99% confidence interval for the proportion of strikes that are critical? This is round to 3 decimal places. Okay, so a couple of things. One of the things you may have to do as you read through this problem is think about what would it mean to be successful here. And a success, as you read through this scenario, is that you perform a critical strike. So when we start thinking about the information we need, X, N, and our confidence level, remember X is the number of successes. So in this case, it's going to be the number of critical strikes. So again, you need to read carefully. Okay, so if I go back and read, in about the second or third sentence, it says a character has 257 critical strikes. So the number of critical strikes is 257 out of a total of 742. So my sample size was 742. And then it wants me to find the 99% confidence interval. Can we write that as a decimal? Now, once I've obtained all of that information, I can plug into my calculator. Now, we use the command 1prop, which stands for proportion, z interval. Okay, so it's a different command from what we had earlier because we're dealing with a proportion. So let me get my calculator pulled up, which I think got closed down, so it'll take just a minute to come up. Okay, as soon as it opens, okay, you're going to go to Stat, arrow to the right 2 times to test, and then scroll down until you see 1prop z interval. I believe it is option A. So let's see. We go Stat, arrow to the right 2 times, scroll down to option A, 1prop z int, which stands for interval. Okay, so there's the option I need, enter. And then I have to tell it how many successes did you have, which was 257. So we enter 2, 5, 7. N was the total out of 742. And we want to do a 99th percentile. Then I arrow down and highlight the word calculate. And I enter. Okay, and it gives me, again, in parentheses, my lower bound and my upper bound. Okay, so let me minimize this and we'll go back and let's write down. It gives us in parentheses 0.30137 at 2.39135. And again, it hasn't changed. The first number in the parentheses is the lower bound. The second number in the parentheses is the upper bound. Pay attention to what you're asked for. It says, what is the lower bound? Okay, it also tells us to round to 3 decimal places. So when I round to 3 decimal places for the lower bound, my answer is going to be 0.301. Okay, so approximately 30% of the strikes were critical strikes in this particular game of World of Warcraft. Okay, moving on to the second example. Sometimes in the question you may get extra information that you don't necessarily need, as is the case in this particular example, because it says, according to the U.S. Census Bureau, 43% of men who worked at home were college graduates. In a sample of 423 women who worked at home, 175 were college graduates. Now, see, this first sentence here, guys, is talking about men, but then the information that you're given is about women. So pay very close attention. It says, what is the upper bound for the 99% confidence interval for the proportion of women who work at home who are college graduates? Okay, so again, as we're thinking about what would be a success here, a success would be a woman who is a college grad. Okay, because that's what I'm looking for or interested in. So X, again, represents your number of successes. N is your sample size, and CL is your confidence level. So be extra careful. Really, this first sentence here is just extra information, guys, and you can ignore it. Okay, so reading, it says in a sample of 423 women, so our total was 423, 175 of them were college graduates, and we want to find the 99% confidence level. So it's really not much different from the first example, other than you have extra information that you don't need that might trip you up. So be careful. So again, we go to Stat, arrow to the right to highlight test, scroll down till you find one prop Z int, INT, it's option A. Select it. My number of successes was 175. My sample size was 423. I'm doing a 99% confidence level, and then I'm going to calculate. And it gives me 0.35203, 2.47539. Okay, so I'm going back to write this down. Okay, so my confidence interval goes from 0.35203 to 0.47539. Okay, again, pay attention. The question says, what is the upper bound? This time it's asked for the upper bound. So what is the upper bound for the 99? Well, the upper bound is the second number in the parentheses, rounded to 3 decimal places would be 0.475. Another question that you encounter in the lesson for proportions is figuring the sample size. How many would you need to sample in order to have a specific margin of error? And guys, this is a formula. It's something that you do have to actually calculate by hand. The formula is on the lesson 18 notes, but I'm going to write it here. To get your sample size in, you need, we call it p hat 1 minus p hat times your critical value for z divided by the margin of error, and that quantity is squared. Now, the value for the critical value for z depends on the confidence level. And those values, the most common ones are 90%, 95, 98, or 99. Those 4 values are on the lesson notes. Okay, so before I start this problem and I read through it, and then I want to try to identify my information. So it says a pollster wants to construct a 95% confidence interval for the proportion of adults who believe that economic conditions are getting better. A Gallup poll taken in July 2010 estimates this proportion to be 0.33. Using this estimate, what sample size is needed so that the confidence interval will have a margin of error of 0.055? Okay, so there's a lot of information that I need before I can actually plug and chug into the formula, because I need p hat, which again is that proportion of success. I need to calculate 1 minus p hat, which is actually the probability of failure. I need to determine the margin of error. And I need to find the critical value for Z for, let's see, a 95% confidence. Okay, so all of this is given in the question except for that critical value Z. Okay, because if I read through this question, okay, it tells me that they estimate the proportion to be 0.33. So my proportion of success is given as 0.33. I can plug and chug to get 1 minus p. 1 minus 0.33 is 0.67. And then it asks me to have a margin of error of 0.055. So my margin of error is 0.055. I can go out to the lesson notes for lesson 18, and I am told in those notes that the Z value for 95% is 1.96. So at this point, I have enough information, and I'm going to plug and chug into the formula. So my sample size would be 0.33 times 0.67 times 1.96 divided by 0.055, and that quantity is squared. Now I'm ready to plug it in the calculator. And guys, I can do that all at one time, okay, working left to right just like I see it. So I'd have 0.33 times 0.67 times, and in parentheses I'm going to put 1.96 divided by 0.055, close up the parentheses, square it, and enter. And I get a value of 280.786034. Okay, so when we do these calculations, we get 280.786034. It asks us to write our answer as an integer, which means it wants it rounded to a whole number. Okay, so I notice the 7 is going to bump to 0, so this becomes 281. So we would need to use a sample size of at least 281.